Hello, my name's Corey, and this is my solution for homework 9-1. We'll start off with the computer class. Computer class holds four nested classes of CPU, RAM, storage, and video card. In order to do that, we have to kind of treat them like they're instance variables of the computer class. So we're creating them here at the very beginning, just like we would with instance variables of any class. We don't have to set them to anything yet. Moving on, we have the full argument constructor. This takes objects that we've created and places them into the computer like instance variables, and then just sets them equal to that. For this toString, we're overriding the toString. We're using the cost method that I'll show later. We're making sure it's formatted in a way so that it says computer specifications first, and then it displays all four components of the computer, and then the total cost of all of those components. And in order to get the toString in, I'm using %s, which is for string format. That's just a way to get a string to take this place. And we're calling on each of the inner or nested classes toString methods, which have all been set up depending on the object. So moving on to CPU. This is an inner class. Its indentation shows that it's inside of public class computer. It has its own instance variables. It has its own constructor with those instance variables. And it has its own overridden toString. Did the same thing with the string format. We're replacing anything with a % with whatever might go there, so it's manufacturer, core, speed, and price. Okay, and we do the same thing with RAM. We're just making all of its instance variables, its toString, and its constructor. Same thing with storage, and same thing with video card. Okay, and then the next thing is the public double cost method, where we're returning this calling objects: video card price, storage price, CPU price, and RAM price. And that's possible, that's totally legal. You can call on this object, so whatever object is using cost, which would be a computer, and then you would find out all of that computer's inner object prices. And you're calling on the inner object, and then you're calling on the instance variable of that object, basically. And that's totally legal. So moving on to the computer builder demo, what we've done is created these objects, the inner objects, by calling on the computer first, so that we know it's an object of type computer that we're making, essentially. It's a component of computer that we're making. And then naming it, and then setting it equal to null. And then we're doing the same thing for RAM, storage, video card, and then we make the computer object using these null values. And it's important to make the computer object for later on, even though there's nothing in it yet. And the reason for that is once we get into the menu and we're creating our first CPU object, we get user input for all of its variables, and then we actually instantiate the object using those variables. And in order to do that, we needed to have the computer object exist first. That way when we call, because we need to use this new kind of formatting here in order to get inner classes to work with outer classes. And what we're doing is we're calling the outer class name, which is comp, and then we're creating a new CPU within that computer, or within that object. Okay? And so that's why we needed to make this with all these null values first. Otherwise it wouldn't exist, and we wouldn't be able to do this. And we do the same thing with RAM. This is the only thing that we've changed with CPU, is made sure to actually instantiate the object using the computer object as its core. And the same thing with RAM. Same thing with storage and video card. And then for case 5, we're displaying the computer. So we have to once again create the computer object now with all the variables that we've made. And I threw in a try catch because this can break the program pretty easily. If one of these is null still, then it just breaks the program and you've lost all the information that you put in, which is kind of annoying. So this makes it so then if you get a null pointer exception, which means that one of these objects hasn't been fully instantiated yet, but we're still trying to make the object using it, then it'll say add components to your computer to display its specs. And I could have gone in and been more specific about which component was missing, but this wasn't even necessary for this project, and I felt that this was enough of an error catcher for the sake of this. Next, to actually add the computer to the shopping cart, we make sure that all the objects aren't null, and then as long as they aren't, we once again, just like in display, we create a new computer object named comp, and then we add it to cart. And this here is enough. I noticed some people were having issues where they thought they needed to make objects of different names, but this essentially is just replacing the old one and then adding it. And then you can keep replacing the old one and adding it, and now that it's in the array list as a different element, it's a different object, and it works. It just works. You don't need to make different named objects in this case. Although, maybe in in a live production scenario, we wouldn't be doing things this way anyway. But yeah, this works for the sake of this homework assignment. So once the object is in the shopping cart, we'll be able to display what's in there. So what I have going on here, we're checking is empty. It's a method for array lists just to see if the list is empty or not. If it is empty, then no computers have been added to the cart yet, obviously, because the cart's empty. And then we're creating a new computer object here called result. And then for the size of the array list, basically for every computer in the array list, we're going to create an object called result from that object and then print out the result. And so what we're doing is just printing out all of the objects in the array list with a space and a computer number, as the instructions showed, as the pictures showed in the instructions. Okay, so that'll print out all the computers in the cart. And then checkout, we just do the total cost, which I still haven't shown that method yet. But total cost is essentially the cost of all of the computers in the array list. And we already have the cost method from computers, which helps us with that. So it just tells us, please pay the total amount of all of the computers in the cart. And then it breaks the loop. Sorry. Once you hit 8, it breaks the loop and tells you to pay. And then for the last thing, the double total cost method, we have a sum. We have to make sure it's 0 because we're using it inside of a loop. And then for every computer in the cart, for each computer of just whatever name you choose here in the cart, we're adding that computer's cost, the cost method from computer, this one, to the sum. And then at the end of that all, we're returning the sum. Okay? And then we'll go ahead and run. And I'll just show you really quickly. We'll just input all the components, just really basic entries here. Okay. We're displaying the computer that's been made. And then we're adding it to the cart, displaying the entire cart, and then checking out. Okay, and that about covers it. If you have any questions or suggestions for something I could have done better, please let me know in the comments. Thank you very much.